So how do we solve the towers of Hanoi? Well, remember our strategy was to solve a subproblem that is one smaller, so n minus 1, and we're going to do it by moving one fewer number of disks from its starting point to one of the poles. But in this case, we're going to use the last pole as the spare one instead of the middle one, because the middle one's going to be the spare for the final problem, and so we'd run into a clash if we used the middle one as a spare for both the final problem and the previous problem. Like, we're going to need a different spare pole and also a different final pole. Let me pull it up for a second, and hopefully this will be a little clearer. Admittedly, it's a little tough to visualize without a picture on screen. Let's imagine all the disks are on pole A for the second. So all the disks are on pole A. We've now got to pick one of the two remaining poles for the place where we're going to leave our solved version of 2. So in this case, we're leaving our solved version of 2 on pole C, which means at the end of the day, we're going to be moving our 3 stack from A to B. Our 3 stack, again, has moved from A to B, but our 2 stack that was moved from A has moved to C. So now we're getting the sense of why we might be switching the poles order in our recursive code for our subproblems. So let's take another look at it. And step by step, we're going to finally build up and understand what's going on. While in this example, we chose pole B as the final one, in our code, we're going to choose pole C. Let's see how that works. Okay, so we have from our main problem of 3 disks, we're moving from A to C via B. If we want to solve it for 2 then, we want the 2 stack, if the 3 stack is to end up on C, we want the 2 stack to end up on B. So from A is from, B is via, C is 2. Given that C is 2, we can't put our disks from the 2 problem onto C. They've got to be on B. B is the via variable. So we use via as the 2 for n minus 1. So for solving the problem for 2, we're going to solve the problem by moving the disks from A to B. B is contained in the variable that says via. So we're moving from A to B via C. C is our spare pole, even though it's contained in the variable 2. This is awfully confusing to say out loud, but it's going to be much easier when you actually sit down and try and draw this out. Remember, the intuition here is that we've actually got to switch which pole we are using for what, because otherwise we'd end up with a pole collision. Like, we can't move, if we've solved the problem on stick B, we can't use stick B as the final place for solving the 3 problem as well. Okay, super confusing line. It even got me muddled for a little second there, but hopefully with a couple of tries, you'll start to get it.
At this point, we also actually have to print the disk that we're moving in between the recursive calls. Remember, the recursive calls only solve the subproblems. They don't move the disk to solve this problem itself. So whether you're on problem n equals 2 or problem n equals 3, once you've solved the easier problem, you have to move a disk, and that's what we do with this printf statement, is we say which disk to move. Why? Because we still have the pile of 2 disks that needs to be moved again. But we know how to move a pile of 2 disks. We just use our Hanoi command again. Only this time, our inputs are going to look a little different. We're going to move the 2 remaining disks from via to via from.
This is probably, I'd say, one of the 2 most difficult concepts in the course to get, so if you're struggling with it, don't worry. It was also a little tricky for me with all the different words that were coming out, but we'll get through it together, and I will see you next lecture.